Hello everyone. Today I am going to discuss about cluster analysis. So let me write what I am going to discuss today. This is known as the cluster analysis. Cluster analysis. So cluster analysis is let me write it in short, CA. Okay. So cluster analysis is an unsupervised learning. Unsupervised learning method. Unsupervised learning method. So now, unsupervised learning method. So what is unsupervised learning? So unsupervised learning is a machine learning method in which there is no response variable or target variable or dependent variable. Any machine learning method that involve response variable, target variable, or dependent variable, that is called the supervised learning. So cluster analysis is a unsupervised learning. What is the purpose of cluster analysis? The purpose of cluster analysis is to segment the entire data in a number of homogeneous cluster so that within cluster variation is minimum, between cluster variation is maximum. So this is the main idea of the cluster analysis. So for example, suppose we have a number of utilities companies. So these utilities companies, they are providing different kinds of services. I want to cluster them. For example, some companies are providing the same type of services, and other utilities companies is producing other type of services. So I want to cluster them. For example, some utilities company provide electricity, some utilities company provides gas, some utilities companies provide water, some utilities companies provide like collecting trash, all of these things. So I want to cluster the companies so that the companies will be put together in a cluster which has homogeneity, and between cluster there is a heterogeneity. Okay, so you have understand what is cluster analysis and what is supervised learning and what is unsupervised learning. So supervised learning is a machine learning procedure where dependent response or target variable is predicted or studied based on independent or predictor variables. Now, one more thing I want to add in here. If clustering is done in a efficient way, then within each cluster, even though clustering is a unsupervised learning, even though clustering analysis is an unsupervised learning, if efficiently clustering analysis is done, then within each cluster, we can conduct very good supervised learning. Okay, so now how cluster analysis is done. So there are two approaches to conduct cluster analysis. Two approaches. for cluster analysis. Cluster analysis. Okay, so there are two approaches. One is hierarchical. Cluster analysis. Another one is k-means cluster analysis. So let me explain what does this mean, these two things. So in order to explain these things, too fast. Second page. So how the clustering analysis is done, now I'm going to discuss. So suppose there are utilities companies. So I want to write here name companies. Company. And then there is a variable such their cost, and they are like producing expenses, cost, expenses, and then some other variables, suppose cost, expenses, salary, profit. So this is the way all of the variable in here. So finally you can put here net profit. Net profit is in here. So here is the name of the company. Suppose name of the company is A, B, C, D, and up until suppose Z is the variable. So suppose there are these are the companies and these are the data. So now these data could be like this is called the variable. This is called the variable or measurement or features. These are the variables, and this is called the observations or rows or record. So these are called let me write here. These are called the rows. These are called the rows or observations or records. Okay, I want to put these companies by incorporating these values, these measurement, these variables. I want to put then companies, these ABCD, like one cluster is in here, one cluster is in here, one cluster is in here, one cluster is in here. Okay, how can I do that? Okay, there are two approaches. One is called hierarchical approach. Another one is called the k-means clustering approach. Hierarchical clustering approach, and another one is called the k-mean clustering approach. So now let me discuss what is hierarchical one. In hierarchical one, so now each of these is called the record, right? Each of this is called the record. Each of this. So there are A to Z. There are how many letters? A, B, C, D, E, F, Z, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. So there are 26 letters, right? 26 English letters. I was confused about 29 letters or 26 letters, because Arabic has a 29 letters. So that's, in order to make it confirm, I just count it in my hand. Sorry about that. So 26 letter, right? So each letter, there are 26 letters. So there are 26 companies. There are 26 companies. Each of these company is called a singleton cluster. Remember the name, singleton. singleton cluster. Each of these company is called the singleton cluster. In hierarchical clustering approach, in hierarchical clustering analysis, what we do, we start with a one singleton cluster, then by computing some kind of distances, we can make 1 to 2, 1 to, we add another with the smallest distance, we can add another one, and then second smallest distance, we can add another one, third smallest distance, we can add another one. In hierarchical clustering, we start with one cluster and keep adding cluster based on distances until all singleton clusters become one cluster, or we can stop. We can stop after computing all the distances. Well, these distances are closest, so this could be one cluster. These distances are closest, so this could be another cluster and that cluster. This is the way hierarchical clustering is done. Okay, now how the distance are computed? How the distance are computed? How the distance are computed? So now suppose this is a two-dimensional X and Y, two-dimensional. Here is a 1 point and here is another point. This one is X1, comma, so X, comma, Y, X1, comma, Y1, and that one is X2, comma, Y2. Okay, so the distance between these is known as the Euclidean distance. Euclidean distance. As distance is, there are other types of distance, but let me discuss only one, and other things you can read from the note that I have uploaded in the online portal. Okay, Euclidean distance is saying that suppose this is the distance D. D is computed by using this formula: x1 minus x2 square plus y1 minus y2 square. This is the way distance has been computed. Now let me explain. Suppose the company A and company B, right? They have a measurement in here. So first one is cost, second one is suppose profit, third one is salary, and fourth one is suppose net profit. Like suppose this is the value is 2.3 and this is 5.6, salary is 4.1, net profit is suppose 1.5. This is the first company. Second company is cost is 1.2 and then profit is 6.6, salary is 4.6 and then net profit is 2.6. Okay, now how can I compute the distance between these two companies? I'm going to show in one cases. So here this is actually vector 1, this is a vector B, I can consider it, or we can do it as a fourth dimensional or P unit. So in this case distance will be D equal to, we can compute is 2.3 minus 1.3 whole square plus 5.6 minus 6.6 whole square plus 4.1 minus 4.6 square plus 1.5 minus 2.6 whole square. This is the way distance can be computed. And after computing pairwise distance for each company, we will find the distance matrix. From that distance matrix, we will start with the one cluster, and among the cluster, where the two singleton cluster has the minimum distance, we will add that one. So then we will have from 26 singleton cluster to now there are 24 singleton cluster. This is a 24 singleton cluster now. Keep adding in here, and this is the one cluster which has a two singleton cluster. So that means one cluster with the two components. So that's the way hierarchical clustering move forward up until all singleton clusters become one cluster, or we can stop by based on criteria. So these are the singleton cluster. They are have the minimum. They are maintaining minimum distance among themselves. So we can put these 4 singleton cluster in one cluster, and then next 6 singleton clusters as another clusters. And that way we can end up with the 5, 6, 7, or 8 clusters. Okay. Finally, when we will get like cluster analysis done, there could be a company, he himself is a one cluster. So that means the distance between that company corresponding to the other is way high. So he wants to stay as himself as a one cluster, known as the singleton cluster. For example, California, New York, if you consider, or maybe Boston or Seattle area, in those area is very expensive area. Okay, their values is unmatched with the other state like the Florida or Arkansas, something like that. In that way, cluster can be formed. Okay, so I mentioned some theoretically how cluster are formed, by hierarchical approach. So if you read the documents that I have uploaded on the online portal, so the cluster mattering 18 pages material, I wrote these things in details, and also PowerPoint slide has been added so that you can learn deeply how the cluster analysis and their computations is done. Okay, I highly recommend that you read these 18 pages, all details, all formulas, and there are different types of formulas, how the distances are computed, and how to handle the distances when the distances are on different measurement scale, are on the different measurement scale. For example, cost could be in a per unit electricity cost could be maybe 50 cents or 60 cents or 70 cents per unit. Per unit thermal for the gas is maybe 50 cents. But the salary is in the thousands of dollars. In such a cases, when the units are on the different scales of measurement, we have to compute normalized distance. So instead of, let me write it here, instead of computing distance in original scale of measurement, it is highly recommended to compute the distance in normal scale. So what is normal scale? Let me explain these things in here. Now, what is normal scale? So suppose you have a cost is a variable, right? COST, cost is a variable, and salary is a variable. So cost here 2.5, 3.1, 4.1, 1.1, 2.1, 5.1, something like this. Okay. So these are the cost. So this is the cost that are in this scale, and then this is the salary that is like 4,000, 5,000, 3,000, and 4,500, 1, 2, 3, 4, then 6,000, and then 5,200. Take a look. Now, if I want to compute the distance between these, if I compute the distance between that distance will be higher compared to the distance if I want to compute another expenses. So per year, how much production cost for producing 1 unit of electricity? So it could be like 0.59 cents, 0.69 cents, 0.79 cents, 0.80 cents, 0.67 cents, 0.90 cents. Okay, so now this distance, by using that distance formula, in this case distance will be way higher compared to the distance if I compare like this distance with that distance, with this one, with that one, like all of these things. So this distance, so that means when the scales are on different when the measurements are on different scale, it is always recommended to transfer the original scale of measurement to the normal scale of measurement. How can I do that? Now, normal scale of measurement, normal cost, normal salary, and normal expenses or normalized expenses. Normal cost. How can you compute normal cost? You can take 2.5 minus mean of cost divided by standard deviation of cost. So you can find the mean of these, you can find the standard deviation of these, and subtract each subtract mean and standard deviation from each values of the cost. You will get a values in there which will be known as the normalized cost. Similarly, you can find normalized salary, so you can find the normalized salary, normalized expenses. This is the way you have to compute distance matrix of the original variables in a normalized scale, distance matrix. So distance matrix, how can you compute? Now the question is, how can you compute distance matrix for the entire data? Okay, so here is a cost, here is a cost, here is a expenses, here is the expenses. So here is a salary, you can write here salary, you can write here salary. Here is a net profit, here is a profit, right? So within distance is 0, so it is 0, it is 0, it is 0 within distance. So now distance between this and that could be computed in here, distance between this and that computed in here, distance between this and that in here. So this is similar to that one is similar to this one is similar to that one. Okay, we will get a normalized score distance matrix. From there we will start adding the singleton cluster together in order to create a cluster. Okay, so this is about all hierarchical cluster. Now let me explain. There are many type of distance matrices. So in some cases, when standard deviation is way higher, then another distance is proposed by the famous statistician known as the P.C. Mahalanobis. in full name Prashanta Kumar Mahalanovis, and he gave a distance formula which is this: xi minus xj. So xi is the record I, xj is the record j, and their variance covariance matrix is this one, I think like this, and then it is put there xi minus xj. What he did in here, he just in within the distance, he just included the standard deviation. In that case, like the some weight will be higher compared to the other. In such cases, if standard deviation or variance covariance metrics are included in computing distances, that distances will be stable compared to the other distances. So there are many other formula for computing distances: Manhattan distance, and then absolute distance, something like this. Those things I recommend you should learn. Maximum coordinate distances, these are the things. Okay. And then there is also other rule to compute measure when there is a mixed data. So there is an unavoidable data. That means that data has some kind of continuous measurement, and some kind of binary measurement, and some kind of non-binary discrete measurement. What do you mean by non-binary discrete measurement? Suppose there is a binary measurement, disease, no disease. Okay, bankruptcy, non-bankruptcy. So this is a binary 1 and 2, 1 and 2, or 0 and 1. Excuse me. And then there is a non-binary discrete measurement or categorical measurement. Non-binary categorical measurement. For example, 7 income level in USA or 9 income level in USA. 1 is the poorest of the poorest. The 2 is the poorest. 3rd is the poor. 4th is the middle class. 5th is the higher middle class. 6th is the rich, and 7th is the richer. 8th is the richest, and 9th is the richest of the richest. Okay, so there is a 1 to 9 level, and also there is the other continuous variable. How can you compute distance matrices when there is a combination of categorical, binary and non-binary categorical data as well as continuous data? There is a formula also to compute those things, and those formula and their explanations are given in details. Okay, I don't want to make the video is 2-3 hours by explaining all of these. Rather, I want to save you time and highly recommend you to read my 18 pages of handwritten note, where each explanation was given rigorously with a small scale numerical computation, so that it will immediately hit to your brain how the computation was done by paper and pencil approach in a small scale problem, and you will not be in problem or understanding how all of this computation in large scale computation is done by using Python. Okay, I think I have given you enough materials to understand. Now let us discuss about k-means clustering. Okay, let us discuss about the k-means clustering. So k means clustering analysis. In k-means clustering analysis, how do we compute the k-mean clustering? So in the k-mean clustering, you are saying the word means we are going to compute the mean of the clusters. Okay, we are going to compute the means of the clustering. For example, Yeah, after doing that, then we will do the clustering process. Okay, first of all, let me tell you what K means clustering stands for. Unlike hierarchical clustering, where we start from each singleton clusters and keep adding based on minimum distance or maximum distance criteria, like all of those things. Here we have to know the number of clustering, how many clusters I'm going to put in this process. So K means clustering means number of cluster K. K equal to how many clusters? K equal to how many clusters? That should be known from our previous knowledge. Suppose there is no previous knowledge of how many clusters we are going to form. In such a cases, we can start randomly from a reasonable cluster number like 4 or 5 or 6, 7 until a stable result is obtained from the algorithm. Now, how the algorithm is done, I am going to discuss these things. Take a look, I am giving the example exactly from the note that I have provided. Suppose we have a one cluster A, which has a company. Arizona is a company, and another company's name is Boston. And then we have another cluster that has three company known as the Central, Commonwealth, and New York. So these are the utilities company. Suppose I just want to make a 2 clusters from these 5 companies. I don't want to take all 26 companies. I just want to take these 5 companies. These 5 companies, I want to compute some distances and all of this, and then later I want to come up with the decisions whether these 5 companies are clustered in 2 different clusters, whether these are good or not. How can we decide that thing? In order to decide those things, we have to find the centroid. So centroid of A and B. How can I centroid of A and B, which could be obtained by X bar A and X bar B. First of all, we have to compute the center. So in order to compute the center, we have to go back to the normalized score of Arizona and Boston. So normalized score, if we take a look, normalized score, we are doing these things. If you take a look at my note that I have uploaded, it should be 0.0459, and then I am adding it with the Boston point. This is negative. I'm finding the average 1.0778 divided by 2, and then I have to consider it 0.85, negative 0.8537 plus 0.8133 divided by 2. So after doing this, I have computed in here, the distance is 516, and then I have another distance in here, negative 0.20. This is the distance. So that means I have in here X bar A centroid equal to minus 516, and then negative 0.020. Similarly, there are three companies in here. I have to add in here these 3, and then I have to add here these 3, and then finally I got this value as negative 0.733, and then I have the value 0.296. 0.296. Okay, so this is the way, because K means cluster, we have to predetermine how many clusters we have. So I took 5 companies instead of 26 companies. After taking 5 companies, I clustered them in 2. I put Arizona and Boston in one cluster, and then Central, Commonwealth, and New York in another cluster, and I computed their I have computed their centroid. I have computed their center. After computed the centroid, from each centroid, we compute the distance. The distance of each record from each of the 2 centroid is given value. So after that, we have to compute the centroid distance. For example, Arizona a computations is obtained when Arizona data, from the Arizona data, we subtracted these and subtracted that by distance formula, we got this. So now let me show you how to compute this. So this is called the, because of K means clustering, K means clustering, I have X bar A and I have X bar B. Okay, now I want to compute these things. Distance from centroid A, and then distance from centroid B. So here I can put the Arizona. Here I can put the Boston, and all the way final company is New York. And then there is a value is 1.0052. I'm going to show you how did I compute this one. Rest of the things you can compute. So rest of these 4, 5, 3, 4, 5. This is what you can compute. Okay, let me show you how can I compute 1.00 for Arizona. From centroid A, I am computing the distance. From centroid B, I am computing the distance for Arizona. So the distance is this. Arizona distance is this. Our value was 0.0459, and then minus and minus, it will be plus 0.516. 516 is this one. Uh-oh. 516 is this one. This is the 516. Let me see if I can minimize this thing a little bit. Yeah. In that way, minimize, so I can. So I put this on, and then again, it is the Euclidean distance I am considering in here. This is the normalized score, and then another normalized score is this one, 0.8537 plus 0.020 square, and then I got here 1.0052. So after doing this, after computing these things, we have found that instead of Arizona and Boston, New York and Boston are closest. So we put New York and Boston together, and then we put Arizona Central and Arizona, Central, and Commonwealth together. Previously, we put Arizona and Boston together. Now we put on the basis of this distance matrix, we put New York and Boston together, Arizona Central and Commonwealth are put together. So this is the way K-means clustering is done. Okay, so the basic theory has been explained in this short video of around close to maybe 45 minutes, 50 minutes, 40 minutes, something like this. Now, let me quickly run the Python program in order to convince you how can we come up with a clustering analysis by using hierarchical method as well as K-means clustering method, and how can we interpret the result. That means we want to get the insight of the result. We want to get the insight, how to explain those findings from the cluster analysis and what insight we have. Okay, so let me open the Python. I have opened the Python in here. After opening the Python, now I am reading all of this Python code. Python code is done. Now I want to, this is the data. Let us see a data d1 dot head. This is the data. That data has 26 companies. If I want to take a look at this np.shape, and then d1 is the data. In this data, we see there are 22 utilities companies and 9 variables. So 9 variable or 9 measurements are these: fixed charge and rate of return, cost, load factor, demand growth, sales, nuclear, and fuel cost. These are the 9 variables, and there are 22 rows. We want to form cluster from this data. We would form cluster of the companies from this data. In your homework one, the data was bigger. Originally, it has a 1300 or 1400 rows. But when I write the homework questions, I ask you to delete any row that has a missing value. And then I checked it. I found it there are 402 rows or something like that. So that means 400 universities in the data you have. From those universities, you have to find the clustering by using hierarchical as well as K-means clustering approach. Okay, let me start in from there. First of all, we want to take a look at this figure. In this figure, we see, this is the figure. From this figure, we see there is a high concentrations of the companies in here. Another concentration is in there. Another concentration is in there. So let me open the figure actually from the materials that I had. How do I have the materials? I think maybe it could be in cluster analysis, handwritten note, utilities, and scatter plot of fuel cost here. So this is the scatter plot. So from this scatter plot, I am taking sales. I am taking sales in this x-axis and then fuel cost in this y-axis. So after taking sales in this x-axis and fuel cost on this y-axis, when I do the plotting, I found that. Let me explain these things. We see one cluster with utilities that have a high fuel cost. So this is the fuel cost. Fuel cost is high. So these are the companies that have the high fuel cost. So these are the company. I don't know whether I can write in there. No, let me see in. So these are the company. These are the company that has a high fuel cost. These are the company that has the high fuel cost. I want to see if I can do something in there, detach from edge. Okay, okay, I cannot do this. So this is a high fuel cost company. Okay, one cluster with the high fuel cost company, and then another cluster with the second with utilities that have a lower fuel cost and relatively low sales. This is a low sales and relatively low sales. Second with utilities that have a lower fuel cost and relatively low sales, and that one, this one, final one, is a third with utilities with low fuel cost but high sales. This is a high sale number is high but the fuel cost is low. So from this 22 utilities company, when I plotted sales in the x-axis and fuel cost in the y-axis and added like the label for each company, we found that there could have been a three cluster based on only two variables. But in reality, I have to use all variables to cluster. That is why all variables, here we are using only two variables, but in reality, we have to use all variables. In such a cases, we have to construct a big distance matrix. Okay, let me take you to the code now. This is the graph you have seen. Now here we are doing Euclidean distance for the matrix D1. Here is the Python code. Here is my D1 data. D1 data is this one. This complete is my D1 data. From this D1 data, I want to compute a distance matrix. So I run it in there. And then I run it. And finally, I run this one, distance matrix. Now, this is all distance matrix. Take a look at that. If you take a look at the distance matrix in these 22 companies, so there is Arizona and Arizona, Boston and Arizona, Central and Central. So diagonal line is always zero because this distance within the same utilities is zero. Between utilities companies, distance is non-zero. So, and distance is always positive. It could never be because there is a square and then a square root in the formula. Anyway, are you saying sum of this is 3900, this is 140, sum of this is 43, 271. So in such a cases, measuring distance will not be feasible because scales are different, so their measurement will be different. So we want to transfer them in the normalized scale. How can I do that? Here is the one approach which is coming from the scikit-learn. Scikit-learn, they uses population standard deviation. For example, let me show you what is the difference between the line number 41 and 43. Line number 41 and 43, line number 41 and 43. What is the difference between line number 41 and 43? So line number 41 use line 41 in the Python code, they use population variance or standard deviation. These things they have used. I goes 1 to n xi minus x bar square. Okay, this is what population variance, or more specifically, they use population standard deviations. And Panda and line 41, line 41 and 43. 43 use sample standard deviations. 43 use sample standard deviation. Line 43 use sample standard deviation, which is equal to S equal to 1 over n minus 1 sum of n I goes 1 to n xi minus x bar. So that is the difference between line 41 and 42. One use population standard deviation, and another use sample standard deviations. Anyway, so let me run these two things. We are going to use the sample standard deviation one. Now, this is a normalized distance matrix. This is a normalized. Now take a look at the how uniform the values are. How uniform the previously the values was ranging from thousands of to like 40, 30, something like this. Now everything between -3 to +3. Okay. Now I want to find the cluster. Before finding the cluster, let us find the clusters by. Before running the dendrogram, that means graph, we want to find the clusters by the name. So here I run. I found that Idaho and Pigott is a one cluster. Arizona, Boston, Commonwealth, Florida, Hawaii, Kentucky, Madison, New England, Northern Oklahoma, Pacific, Southern Texas, Wisconsin, United, and Virginia is another cluster. Central is a one singleton cluster. San Diego is a one singleton cluster. Nevada is a one singleton cluster. New York is a one singleton cluster. So there are 4 singleton cluster and 2 other cluster. One cluster has two utilities company, and other cluster has the log rest. So let us, as you have seen this, the cluster 6 cluster, let us see this cluster by using dendrogram. Here is the dendrogram. From the dendrogram, that we see, we use the single. Single means minimum distance we have used in here. Single means minimum. If you read my class note, handwritten class note, you will see that. This is the dendrogram. Now take a look at that. New York is just only one singleton cluster. Nevada is only one singleton cluster. Okay, Nevada is only one singleton cluster. San Diego is a only one singleton cluster. Okay, how? Take a look at that. Nevada is one singleton cluster. New York is a one singleton cluster. San Diego is a one singleton cluster. Idaho and Puget is a one singleton cluster. Come to the graph. Idaho and Puget. This is the Idaho. This is the Puget. They have the same. Okay. And then central. This is the central. This is the central. This is another one. Come to that one. Central is another singleton cluster. So we have seen that in this format as well as in a graphical format. And rest of this, all of these are considered as a one. These are all considered as a one. These are considered all of this because their distances is almost same. Rest of those distances are little different. Okay, so this is what the dendrogram can be obtained by minimum distance, maximum distance, average distance. The next one is obtained by the average distance, but there is a similarity. Take a look at that. So in that case, if it is run, so let me do these things. This is called the cluster by maximum distance, single distance, and if it is run in here, let me check in there. IPython. Here, Idaho, Nevada, Puget in one distance. San Diego and New York. San Diego and New York is singleton cluster. So Nevada and New York. See, New York and San Diego. Sorry, New York and San Diego is a singleton cluster. Let us take a look at that. This is a New York, and where is the San Diego? Yeah, this is the San Diego. This is the New York. This is the San Diego. This is the New York. Nevada, Idaho, Puget. These are sent in one singleton cluster. Nevada, Idaho, and Puget. Nevada, Idaho, and Puget has been put in one cluster. And then Hawaii, New England, Pacific, United is another cluster. Arizona, Central, Florida, Kentucky, Oklahoma, Southern Texas is another cluster. This is another cluster. Well, so the reason is different between these two hierarchical clustering approach because they are using different method, different distances. One is using single linkage, another one is using average linkage, average. So if you read those things in the materials that I have given From that, you will get the result. Okay, I also provided a book name from where I have prepared the lecture. In the homework, you can read that. In homework instructions, I gave clear instruction how to solve this problem. I have given you the code, given you the explanation, so you just need to manipulate my code in order to do the homework. Okay, now after doing the clustering, let us do the heat map. Heat map of this cluster, and then we need to explain something from the heat map. Control Z. Come here, take a look at the plot. This plot, take a look what I am discussing in here. Are you saying 2, 1, 0, -1, all of this? So we want to focus on the 2, 1. So take a look at the cluster number 4. The cluster number 4, where this black one has the highest value of 2, and then this maybe purple, this is the highest value of in here, and this is corresponding to cluster number 4, and cluster number 4 has a high nuclear energy. So if I want to if I want to read it from there, I have to read it in here from, how did I write? Heat map. So we see that cluster 4 is characterized by utilities with a high % of nuclear powers. So cluster 4 is highlighted, or cluster 4 is characterized. Cluster 4 is characterized by utilities with a high % of nuclear power. With a high % of nuclear power, this is the cluster 4 is characterized. Cluster 5 is characterized by high fixed charge and ROR. Cluster 5, this cluster 5 is characterized by the high fixed charge and ROR. These two things. Why high fixed charge? Because these 2 and 1, these are the values where the black part and this purple part is lying. So that is why cluster 5 is characterized by the high fixed charge and rate of return. And then cluster 2 has a high fuel cost. Cluster 2 has a high fuel cost. This is the cluster 2. And then if you take a look at the fuel cost, cluster 2 has the highest fuel cost. This is the cluster 2. That's the insight. How you have to explain the your findings from cluster analysis. In your homework, whatever you have found from the heat map, you have to write 2-3 sentences, 4-5 sentences, how to explain the heat map. So how to explain the dendrogram, and how dendrogram result is consistent with the clusters together with their name. We got the output from the Python. From the Python, we got the cluster number and the elements in the each cluster. We have to take a look, we have to match whether that result is consistent with the graphical representations of the cluster by dendrogram. Okay, so that is the explanations of the heat map. Now let me go there again on the k-means clustering. In order to do the k-means clustering in here, we applied here C, M cluster equal to 6. As we have seen 6 cluster, we have to put here 6 cluster. Suppose, that is why I asked that when you will do the clustering, do the hierarchical clustering first. In that way, you will get some idea of how many clustering could be done. And the same number you just put in the k-means clustering with the 6 cluster, where they will find the centroid of each cluster. After finding the centroid of each cluster, they measure the distance by Euclidean distance and then compute like the distance from each cluster to each centroid, and then they compare whether their cluster is good or not, or they need to rearrange the clusters. Okay, so the basic idea of k-means clustering is to use some kind of predetermined cluster number which you will have to have from previous knowledge, prior knowledge. So after running this, we got in here, when we use the k-means clustering, we see that Nevada and New York is singleton cluster, like the way in the hierarchical clustering we got Nevada and New York as a singleton cluster. Nevada and New York as a singleton cluster we found by using hierarchical clustering, which is confirmed by the k-means clustering Nevada and New York. In addition, Idaho and Pagat was also a cluster in hierarchical clustering. So we got 3 complete matches, and others was also matching. We are getting almost same result. Few companies switches between cluster 1, 2, and 3. There are 6 cluster. First cluster has a level 0, and then second cluster has a level 1, and the 6th cluster has a level 5. Okay, so after doing this, we have to find the centroid that we computed by paper and pencil approach. This is the way centroid needs to be computed. After computing centroid, we are going to compute the within cluster distance. So we have found the cluster 1 and cluster 3 has the highest variability within the cluster. Within the cluster, most heterogeneity exists in cluster 1 and cluster 3. Cluster 4 and 5 would not have any within cluster variability because that is a singleton cluster. Okay, so the singleton cluster, that means that cluster has a mean and then 1 observations. That 1 observation and mean are the same. So if you find the distance, that is distance will nothing but the 0. And then the lowest within cluster variability is for the cluster number 2. Cluster number 0, which is the 2 member, which is 2.54. That's the way you have to explain the within cluster variability. Within cluster variability, you have to explain. So Euclidean distance from the centroid has been computed. Now we are going to do the profile plot. There is a good explanation needed from this. So this is the profile plot. Okay. So 6 cluster, and with respect to what we are doing in here, there is a centroid values, right? Computed centroid values. So corresponding to each cluster and their corresponding measure, each measure has a centroid value. We have plot those things. This is called the profile plot, and we want to check. Take a look at the cluster number 4, which has the highest variability from fixed charge, which is -2, and the highest value is at the sale, which is equal to almost 2.8, something like that. So from there, we can analyze that from profile plot of the cluster, we see the cluster plot, cluster 4 has the highest variability for the 2 measurement, which are fixed charge and nuclear. So we see that cluster 4 is characterized by especially low fixed charge. So low fixed charge and then highest sales, right? This is the way we can characterize. We can characterize the cluster 4 by the low fixed charge and the highest sales. High sale and then high demand growth as well. So that is also a highest point, one of the highest point, that is a high demand growth and high sales. Now, we also notice that the spread of the cluster for sales and fixed charge is quite high. We also notice that the spread of the cluster for sales and fixed cells and fixed charge spread of the cluster. We also notice the spread of the cluster for cells and fixed charge is quite high. So fixed cells and fixed charge. So this cluster, we also see that the spread of the clusters for cell. So these are the clusters, right? Among this cluster, the spread of the cluster is the high. We also notice that spread of the clusters for cells and fixed charge is quite high and not so high for the other. So spread of the cluster, because take a look at that. These are the variables. Okay, these variables or these measurement are spreading by the clusters. So 1 cluster, 2 cluster, 3 cluster, up to 6 cluster. So the fixed charge and cells, these are the two measurement mentioned in here. Cells, spread of the cluster for cells and fixed charge is quite high, spread of the cluster. So spread of the clusters for cells and fixed charge is quite high. This is going like this and going up and coming and again huge jump. So that is what it. After doing this now, this is a suppose you are not familiar with the hierarchical cluster. Instead, you are familiar with the k-mean clustering. So from the data, how can you determine how many cluster you should do? This chart is known as the elbow chart. This chart is known as the elbow chart. How can you do the elbow chart? Elbow chart, you have to run the code 142 to 152. So if you run this, and then if you take a look at the files, so in this case, you see, if there is a 1 cluster, average within cluster square distance is very high. If you took the 2 clusters, then this is also 75 variability. 3 cluster is going down. 4th cluster is enough. And then after 4, if you make more cluster, then variability is not that much from here to there. So that is why if you also take 4 cluster analysis, then it is a perfect. So if you want to do, suppose one of the students, he did it other way. How he did other way? One of the student does the homework other way. He first ran this code for the university data that I provided. From that, he got a elbow chart. From that elbow chart, he decided that, well, I will do 4 or 5 clusters, because after that, the variability is not that much. So he can take the 4 cluster. He first did the 4 cluster analysis. After doing 4 cluster analysis, and then he did the hierarchical analysis. And then hierarchical analysis he does, then he described these things exactly opposite way, like the way I describe. I describe by first analyzing, first doing cluster analysis by hierarchical approach, and the number of cluster is 6 that I pick up and put in the k-means clustering, number of cluster equal to 6, and got the result. If any student do the opposite way, I will also give them the same credit. There is no punishment for that. Instead, I will appreciate that. Okay, I think that's all about cluster analysis. I'm going to stop in here. Have a good day. Bye.